All right, let's take a look at your assignment, see how you did on our confidence interval, confidence level interpretations, and then also some of those multiple choice questions on margin of error. So here we go. A recent survey of 500 people had reported that 67% of Americans believe that high gasoline prices are caused by greed of oil prices or oil companies. Margin of error 3% was reported. What does that mean? So, I know that that's going to make my interval go from 64% to 70%. So, does it say that no more than 70% of the population believes that? And that's a no. I'm just 95% confident, or whatever confidence it is, that the true proportion is between 64 and 70. So, that's not correct. See, and just like this, I do not know that it's actually in there. I just am so much percent confident, whatever that is, that it's between 64 and 70. All right, here we go. See, this is interesting because, I'm 95% confident that the true proportion is between 64 and 70, which means that it would be unlikely for me to get that 67% unless that true proportion was somewhere around there. Okay, so my interval I would not have gotten an unusual interval, generally speaking. I would have gotten an interval that leads me to conclude that the true value is somewhere within that 3% margin of error. Okay, so 3% of people were not served. I don't even know what that is. And 3% of the time, no. Okay, so we want to reduce the width of a confidence interval. So a couple different ways we can reduce that width. So confidence level and sample size. So reducing the width would be reducing the confidence level. Reducing the width would be increasing the sample size. So let's see what my options are. Increasing the sample size, okay? So they didn't say anything about here, none of these will result in a smaller confidence level. I don't know what that is. Okay, moving on. So here we had a free response question. This is an actual AP question where you were asked to estimate. Here we go. Construct and interpret a 95% confidence interval for the proportion of all customers who, having asked for a cup of water when placing an order, will fill, so that's present or future tense, the cup with a soft drink from the beverage fountain. So that is okay for me to use for stating what my proportion is that I'm going to infer about. So I'm going to do my panic model. So my proportion of all customers who, having asked for a water cup when placing an order, will fill the cup with a soft drink from the beverage fountain. And so then my assumptions, it was stated a randomly selected 80 randomly selected customers who ask for a water cup when placing an order. 80 is less than 10% of all such customers. And then for our large enough, then these were our results. We had at least 10 successes and failures, so the approximately normal model applies. FYI, do you see over here how this is panic, the P-A-N-I-C? This P is the proportion. That's a variable. This is not P for panic. This is the P for proportion. It's a 1 proportion Z interval for the name. And here's my information. Here we go. Oh, I forgot to put a line on that. So here was the P hat I got. Because this was an actual AP question, I kind of kept on. Look at how exact I was. Okay, so I kind of kept all my decimals there, and so here, even there. All right, so that gave me an interval. So I am 95% confident that the true proportion of all customers who, having asked for a water cup when placing an order, will fill the cup with a soft drink is between 18.8% and 38.7%. Now, let's see what Other question. Okay, so now they ask another question based on this. So see, you're going to be using this interval in subsequent questions. If this interval was wrong, then they would follow your incorrect interval through, seeing if you used it correctly in the remainder of the problem. You could still get full credit for the remainder of the problem. All right, the manager estimates that each customer who asks for a cup of water but fills it with a soft drink costs the restaurant 25 cents. Suppose the month of June, 3,000 customers asked for a water cup. 3,000 customers asked for a water cup, and this is the proportions of them who were going to fill it with soda. Use your interval from part A to estimate the cost for June, the month of June. All right. So first I want to say, okay, what's 18.8% of the 3,000 customers and what's 38.7% of the 3,000 customers? So I can get a percent of the customers. And there it would be. So I'm 95% confident that between 564 and 1,161 customers fill water cups with a soft drink. So now then I do that at 25 cents per customer. So then I change it to money. So that's 25 cents per, that's a 141 to 290.25. So I am 95% confident that the cost to the restaurant in June for customers filling the water cup with soft drinks is between 141 and 290.25. Okay? All right. Actual AP question right there. What year was that? 2017. So relatively recent. Okay, here's another one. Look, 2018. So here we have this. We are environmental science teacher at a high school wants to estimate the proportion of students at the school who regularly recycle plastic bottles. The teacher selects a random sample of students. Each selected student went to the teacher's office and one at a time. So they say, okay, we're doing privacy there, and was asked to respond yes or no to the following question. Do you regularly recycle plastic bottles? So hopefully you suspect something with this scenario. Um, so let's keep going. Based on the responses, a 95% confidence interval for the proportion of all students at the school who would respond yes to the question 0.584 to 0.816, 58.4 to 81.6. Okay, so that seems like a lot of people are going to do that. Here we go. Next, how many students in the sample were selected by the environmental science teacher? Interesting. What was it was a 95% confidence interval. Remember that to figure out this sample size, I need to know this margin of there's kind of a lot of things here I got to know. So let's walk through it. So one is that I got to know this margin of error. Okay? So here's what first goes through my mind is that I need to use that formula that was this. The margin of error equals that critical value times that standard deviation. Okay, so if that's the case, and then we're going to solve for n. So this is ultimately what we're going to solve for. How many students were in this sample? Okay, so at this point, I need to start figuring out how can I get this information from what I've been given. So remember this. Think about what this interval is physically looking like. The lower bound is 0.584, the upper bound is 0.816, with p hat being in the middle. So see, that's the average. So that makes the average 0.7. So p hat, so then I know p hat is 0.7. From that, I can then say, okay, how far is it from 0.7 to one of those bounds And so that then is the margin of error. Once I have that, then I have the margin of error, 0.116. Critical value, I can find because it was a 95% confidence interval. And then p hat and 1 minus p hat, I can fill in. So here's what I have. Critical value is 1.96. Standard deviation is that. And so here I have it over here on this right-hand side. Fill it in right here. See, this right here was the key. Getting these parameters over here. And so then that's 59.95. So I said, it seems as though the teacher sampled 60 students. Okay. Now, next question. Given the method used by the environmental science teacher to collect these responses, explain how bias might have been introduced. So this is two things. And describe how the bias might affect the point estimate. What is the point estimate? The point estimate is that p hat. That is that p hat that was affected. How was this different than probably what it should have been? That's the big deal about this part of that question. So here we go. So first of all, I think bringing the kids into the office to ask them this question, it's going to kind of be lack of privacy because it's socially desirable to say that you recycle. So, see, the students were stating in front of the teacher if they recycle, and it's socially desirable to recycle. So the students may have felt pressured, maybe responding yes to the question because of lack of privacy, response bias, any of those kinds of discussions that you allude to. But that's only half credit for this problem. The other part of it is, what is that numerically doing to that point estimate of 0.7? And here it is. Therefore, the estimate of 0.7 or 70% is probably an overestimate of reality, of the true proportion of students who regularly recycle plastic bottles. Okay? Two-part question. If you didn't answer that second part, you have lost a point. Okay? Out of 4. All right. Next. The statistics teacher at the high school was concerned about the potential bias in the survey, so to obtain a potentially less biased estimate, here's what she came up with. A random sample of 300 students was selected, and each one was given the following instructions. Here we go. You're going to flip a coin, like to the side. You're going to flip a coin and see what you get. And if it's heads, then you have to respond, no, you do not recycle. Okay? Regardless of whether you recycle or not. But if it's tails, then you can say the truth. Okay, so now we're going to guide us through what this ramifications of this sampling design do. So what's the expected number of students from the sample of 300 who would be required to respond no because they got heads on the coin? So that, of course, is going to be 50% of the 300. So I expect 150 students on average, because expected value is the mean, are going to be saying no just because they had to. All right, so next question is this. So the results of the sample showed that 213 of the 300 said no. Okay? So, got to keep that in mind and keep it straight, yeses and nos on this question. I noticed I was almost tempted to give the opposite answer because I didn't keep my nos and yeses straight. So, watch out for that. Based on the results of this sample, give a point estimate for the proportion of all high school students who would respond yes. Okay, so if 213 respond no, then and 150 had to say no, then that's 63 of the remaining 150 who answered no because they actually do not recycle. So then 87 of the 150 responded yes, that they do recycle. So that makes 87 out of 150. So that means the true proportion of the point estimate for the proportion of all students who respond yes is 0.58, okay, which is less than that original estimate of 0.7. So there could very possibly have been some bias. Bias shifts that whole set of data higher, okay? All right, that's it, I think. Is that all? Yes. This is a good page just to kind of get you started. It reviews what all was going on in this whole unit, okay? So here was your one proportion Z interval. It lays out what each of these things are. See, here is your sample proportion, also known as your point estimate. Here is, each one of these whiskers is a margin of error. And see, here's your lower bound. That's because of the subtracting. And here's your upper bound because of the addition. And then here's an example. See, look here, your p hat is exactly in the center. And then you have your lower and your upper bound. Now, here is what the conditions were. And then here is also a succinct statement of the interpretations of interval and confidence level. Again, notice on confidence level, you do not even mention the interval. Confidence level is about the many, many, many samples that will contain or capture the true population amount. Okay. So there we go. That's a summary page. And then you are going to work on the warm-up so that you are prepared for your quiz tomorrow. All right. I hope you did well on those.